You've certainly heard about the metaverse, how you can create models of your environments, people, things, everything, and access that data through graphs and then through interfaces like HoloLenses, but also other types of interfaces. An interesting scenario is to rewind the metaverse. Try and go back in time and look at the data that describes your environment a day before or a specific time earlier on. So we're going to rewind the time, and that's going to be with Taylor today, explaining how Azure Digital Twins combined with Azure Data Explorer allow that. That's today on the IoT Show. Hi everyone, this is the IoT Show. I'm Olivier, your host. Thanks for joining us. Today we'll talk about rewinding the metaverse. So that's a pretty nice and neat topic. Back to the Future is the t-shirt I'm wearing today, and that's what we're going to do with Taylor. Taylor, how are you today?
Good. Thanks for having me on the show, Olivier.
Thanks for coming. So today you're here for telling us about new features in Azure Digital Twins, which is a service that you're going to give us a little refresher on, and that allows creating models and interacting with environments and their state, right, their current state. But as we'll see, it could be interesting to go back in time on that data and see how your environments are doing. So that's the topic of the day. Before we jump into that, Taylor, tell us a little bit about yourself. Who are you? What are you doing at Microsoft?
Sure. I'm a program manager with the Azure Digital Twins team, and I focus on integrating the Azure Digital Twin service with other services, such as Azure Data Explorer.
Nice integration. I like this story because creating applications is about integrating different types of services. And here within Microsoft, we're doing that, and we'll talk about that today to give more features and functionalities to our customers. So before we jump in there, Digital Twins, give us a very quick refresher. We have other videos about it, but in the context of today's discussion, tell me a bit about Digital Twins and what it is.
Sure. As you can see on the slide here, at the very center of Azure Digital Twins is what we call the digital twin graph. And this is a digital model of your environment, whether that environment is a smart building, a smart energy grid, or a factory. And within the Twins graph, we have different nodes. Each one of those nodes represents a twin. So that could be a substation, it could be a machine press, or it could be a switch on a track. And you create those twins from models, which you define in the digital twins definition language. So each one of these nodes represents a digital twin, and then we connect those twins together through relationships. And then we host that digital representation in the Azure Digital Twins live execution environment. And then we bring that digital representation to life with data from the real world. That data can come through IoT Hub or from Logic apps or through applications that call a REST API. And then client apps interact with that twin graph, typically by querying it. So client apps want to traverse the graph, traverse hierarchies, or look at the state of individual twins. And then one of the other things we can do from Azure Digital Twins is trigger events, such as when twins change, and those events can be used to trigger downstream services, or we can even exhaust twin changes and historize that to services like Azure Data Explorer.
Okay, so that's interesting. That's a great way of introducing digital twins. Actually, one of the best ways I've heard so far. So I like it very much. Thanks, Taylor. So you just mentioned, historical data here real quick, but we're going to dig into that a bit more. Digital Twins, or Azure Digital Twins, as a matter of fact, as a service until now, was kind of offering a last known state view of your environment. And here we're talking about going back in time and looking at the data that was actually set into the digital twins or around it in a previous moment in time. And so what are the scenarios? What is it that the customers are asking for here? Like, give us some examples.
Yeah, we've been getting some great questions from customers about how they can combine Azure Digital Twins with historical data or time series data. So here's some example questions that customers have asked us that they'd like to answer. How did the temperature of the 4th floor on the Cotoso building respond to thermostat changes over the last 12 hours? Or how did the power demand change for substations feeding the football arena during Saturday's game? Or how was the rate of production impacted on lines A and B in Factory 27 during the supply disruption last week? These are just some of the questions that we've gotten from customers.
Interesting.
And
yeah,
sorry, please go ahead.
Yeah, no, I was about to ask, and you're just following up with that, which is there's some things in there that are telemetry related or very much IoT related, and other things that are actually more about the environment and are more static, right? A building map or a location of a room compared to a floor, etc. So I was about to ask, tell me a bit more about what's in these in terms of complexity. What are the challenges in gathering that data?
You're spot on. If you look at each one of these questions, there really are two key components. One of those components being time series data. So the temperature over the last 12 hours, the power demand during Saturday's game, or the rate of production last week. But then we also have a part of this question which really relates to a hierarchy or a topology or a twin graph. For example, the fourth floor of the Contoso building, or substations feeding the football arena, or lines A and B in Factory 27. And so part of these questions really are best modeled through a twin graph where we can model relationships and hierarchies. But then the other part of this question is really best modeled in historical time series data. And what we really want to do is reason across both of these data sets to answer questions about the behavior of modeled environments over time. And with so many sensors capable of producing data, we've learned that customers really need a way to contextualize that data to understand the behavior of different signals, different machines, and different entities within a broader environment.
That makes sense. Interestingly, this seems to be a big duh moment, right? It's like kind of a, I want to do that. It should be available and right available to me. And that's what we are enabling here with that combination or integration of Azure Digital Twins and Azure Data Explorer. So you described Digital Twins. Data Explorer is a database engine for time series data, right? So tell me more about that.
It's an incredibly powerful relational database capable of ingesting and analyzing data, very large data sets, and supporting ingestions at very high data rates. So it's a very powerful tool that pairs quite nicely with Azure Digital Twins. And if we look at data history and the feature that really was the result of these customer questions, it's an integration between Azure Digital Twins and Azure Data Explorer. And when you use the data history feature, what you do is you create a connection. And that connection allows us to record digital twin changes to Azure Data Explorer to historize those twin changes over time. So imagine that anytime you update a digital twin, the data history connection takes that update and then sends it out to Azure Data Explorer and stores it in a data history table. And then once stored, you can run joint queries to reason across both the twin graph and the time series data.
Okay, sounds pretty logical, and we'll see that in action, right? So you have demo. So let's look at how it works.
Okay, so let's get into the demo here. And the first thing we're looking at right now is the Azure Digital Twins Explorer. And what this does is it allows us to visualize the twin graphs that we create within the Azure Digital Twins service. And for today's show, I created a very simple twin graph here. This is a twin graph of a dairy operation. And in this dairy operation, we have two factories. We have a Stockholm factory and we have an Oslo factory. And at each one of these factories, we have different nodes or twins. So we have a twin of a technician. In this case, we have Philip, and you can see these lines here represent relationships. So the factory employs Philip, and then Philip maintains a pasteurization machine, and he also maintains a salt machine. And then we can see that the pasteurization machine feeds the salt machine. So in this very simple example here, we have different types of twins based on different types of models, and they're connected together through relationships. And then on the right-hand side, we have a more complex digital twin of the Oslo factory. So what I did was actually, I created this example through a new capability called the Azure Digital Twins data pusher. And what this data pusher does is it makes it really easy with the click of a button to actually set up this example scenario here. So with a click of a button, it created the entire twin graph, and it created the models, the twins, the relationships, and then it started pushing data into it. So you can see here that once a second, it's
Nice.
updating all of those twins with new data.
And you're saying, Taylor, that's part of the tooling here? That's something new, right?
We've added it to the tooling, and so we'll be providing a link in the documentation where you can access this link. And if you're new to Azure Digital Twins or you want to play around with data history, with a click of the button, you can create this very same twin graph and then send data to it and get up and running pretty quickly.
Nice, very practical. Love it.
Yeah, so once we have our twin graph up and running, we're updating the state of those twins. Each one of those twins have property like inflow and outflow, temperature. The next step is to set up our data history connection. So let me go ahead and pull that up. All right, so what I've done is I've jumped over to the Azure portal here, and I'm looking at an example of an instance that I've created. This instance doesn't yet have a data history connection. I did create one for the one we were just looking at. But what you'll see here within the data history, within the portal here for my digital twin is a new item here called data history. So if I click on that, I'll start a new wizard, which allows me to create the connection to the resources downstream. So if you recall the previous view, we're going to send data from our ADT instance to an event hub, then to our ADX cluster. So I go in here, I click create a connection, and then I'm going to select an event hub. So the first thing I'll do is I'm going to select the subscription I'm using, and then I'm going to select the namespace. So recall here that I've already provisioned my event hub, I've already provisioned my Custo cluster. So at this point, I'm just connecting things together. There's the namespace that I'm using today. And here's the event set hub that I've set up. And then I'm going to select the consumer group here, the default consumer group. Those are the parameters that data history needs to describe the event hub. And then after that, I need to go ahead and select my Custo cluster or my Azure Data Explorer cluster, a different term. So I go in here and I select my cluster. I select the database I'm using, and then I'll let the setup here name the new table for me. And then I go through and I enable a set of role assignments. And these role assignments are necessary so that my different resources can talk to one another. Okay, so there we go. I've enabled the role assignments. And then the next step is for me to click next and then create the connection. So fast forwarding a little bit, my connection is set up. Let's go ahead and look at the data that's sent from Azure Digital Twins to our Azure Data Explorer instance. So let's jump over there.
Yep.
Okay, so now I'm in the web view here for my Azure Data Explorer cluster here. And what we're looking at right now is the schema of the data history that's being sent to it. So I've run this first query here, and all I've done is I've taken 100 records from my data history table. And you can see here we have a timestamp field, an ID field. The ID field is going to be the ID of the twin that had a change, and then the ID that the twin was created from, and then a key value pair. So we can see here that for pasteurization machine A01, at this time, the inflow property was changed to 148 gallons per second, for example. And so you can see all the other records of the other twins as they change over time. So first concept is we're successfully historizing the changes as they flow into Azure Data Explorer. Now, the other powerful concept is that from within Azure Data Explorer, we can query the twin graph we looked at earlier. So for example, here, I've got a short query that retrieves all the factories in our twin graph. And how does it do that? Well, it does it. We have here an ADT query. So this is a short query where we go out and we select all twins that were created from our factory model. And then we use the plugin here. This is the Azure Digital Twin plugin for ADX. And so if we click this, we're going to get back the Oslo factory, and the Stockholm factory. So we're able to not only query the data that lives in ADX, but we can query data that lives in Azure Digital Twins. And where we're going here is we're going to show how powerful it can be to combine these two data sets.
Right.
So a couple more quick examples of how we can create more advanced queries against our twin graph here. So let's say we want to see all of the operators who are employed in the Oslo factory. So we have a slightly more advanced query here. You can see we have a match statement, which uses a gremlin expression. So we're going to look for a factory that employs a person, where that factory is the Oslo factory. And we can see that Amy, John, and Zena are all employed in the Oslo factory. And then just extending the example once more, we can also get all the machines maintained by John in the Oslo factory. In this case, we're looking for a factory that employs a person that maintains a machine. So here we can see that John, who works in the Oslo factory, maintains two machines, pasteurization machine AO2 and AO3.
Okay.
So the next step is to combine this graph information with the time series information. And I've got a couple of examples to walk through, if that's okay. So this first one, let's say we want to analyze machines that are maintained by a specific technician here. So we're going to look at the 1 minute average outflow of each machine maintained by John in the Oslo factory over the past hour. And to do this, we're going to have that same graph query, and then we're going to join it against our time series data and do a little bit of aggregating on it. But when we run this, we got a little bit of the gap in the data because I suspended my data generator before we got started here. But in this case here, we can see we've got the average outflow for machines maintained by John in the Oslo factory. And so we can continue to look at different ways of analyzing the performance of our environment and the behavior of the environment to really bring context to all the time series data that's flowing into the cloud. So just a couple more examples. Let's say we want to sum the outflow from all machines that feed a particular machine. So if you remember, we have a salt machine and it's being fed by pasteurization machines. So again, we start off with a query here to identify those machines that feed salt machine C0. And then we do some analytics to sum their output. And then we've got another chart here. Or lastly, one more here, we can also compare the behavior of entire factories. So I can look, in this case here, I can chart the maximum 1 minute inflow of any machine. Here we go. Sorry, I skipped the wrong one. We can compare the total outflow from salt machines in the Oslo factory to all the salt machines in the Stockholm factory. So again, just doing different graph queries, selecting different twins of interest, and then joining those twins against time series data and performing aggregations. So one of the things we do hear from a lot of customers is, okay, these queries are powerful, but how do we build an application on top of that? And so for a lot of folks, they're going to build a web application. Other folks, they may want to get started with just the dashboarding, a business intelligence tool. So Kusto integrates a lot of different tools out there, Tableau, Power BI, and Grafana.
And so I was about to ask actually exactly that, which is, how do you go from using that dev tool at the end of the day, which is like Kusto SQL, query language, which is part of that tool that you're showing here. But yeah, the application is to be built, and you need to make that information, that data available to operators, right? Not just you really stuck to the scenario. I love that, which is like I was in the context of these factories and understood exactly what you are demoing here. So here we're talking about offering interfaces for this data, this combined data through ADX, through Azure Data Explorer, to apps so that operators of different kinds or business people can look at the state of things and so on. So yes, so definitely I'm curious to see some examples of that as well, how it looks on the other end.
Yeah, so if you look at a lot of these queries, we start off with a bunch of parameters, and what we can use is we can use those parameters to drive menus, for example. And so I prototyped a web application here using, in this case, Grafana. So let me see if I can pull that up here. And so if you could see here, we've got some menus at the top here. Mm-hmm. in our first menu here is the factory. So if you recall earlier, we had a query where we retrieved all the factories here, and that's exactly what drives these menu selections. So this first menu here is driven by a query to Azure Digital Twins. It's actually proxied through ADX. And what happens is these downstream menus are impacted by the selections I make. So for example, if I pick the Oslo factory, this will go out and it will then retrieve all the folks that work at the Oslo factory, as we saw earlier. And then if I pick John, then we can dynamically see the machines maintained by John, and then we can look at the parameters for those machines. So the idea being here is that we can build a user experience where we can drive these selections based on dynamically going out and exploring the relationships within the twin graph. And this is a common pattern for a lot of Azure Digital Twin applications, where the user will go through some kind of hierarchy traversal where they'll drill down and then they'll finally arrive at the twin of interest. And in this case here, we just have a time series chart and then the current value. So you can really explore different business intelligence tools and come up with different hierarchical navigations and traversals based on the twin graph you create in Azure Digital Twins.
That's great. I started with that almost joke about rewinding the metaverse, but here we're really demonstrating how you can really integrate that real environment with real-time data, but also with historical data, with that digital world, and then offering that interface, which is at the end of the day seamless, right? We talk about the metaverse with people accessing data through HoloLens. But in reality, Metaverse is going to be a lot more about this kind of interfaces, right?
Exactly. And, really at the end of the day, it's helping customers get more out of the data that they're bringing to the cloud and being able to create meaning and extracting business value from that.
Yeah, I love that. I've got one more last little question. I don't know if it's nitpicking, but I think it's interesting to look at that real quick. So in the diagram you were showing that the data is actually flowing through Digital Twins, and Digital Twins is pushing that to Azure Data Explorer. What about customers who are already pushing directly to Data Explorer? So can they still benefit from that integration and have this navigation through data that is both like hosted on Digital Twins and ADX, even though they're not sending the data through Digital Twins first?
Absolutely. If you're sending IoT data into Azure Data Explorer, you can use the plugin, as we saw earlier, and run the Kusto queries just as we saw. So the data history makes it really convenient for you to contextualize data and then maintain state within Azure Digital Twins. Of course, the benefit of pushing data through Azure Digital Twins is you have that state representation and you can trigger events based on state changes. Alternately, if you're already sending data to Azure Data Explorer, then you can use the plugin, as we saw earlier, to then run joint queries to reason across both the twin graph and your time series data.
Love it. So don't change your architecture, continue as you are, just leverage this new plugin. Perfect. Exactly. Awesome. Yeah. Taylor, great presentation, great demo, really a nice insight into this new capability of Azure Digital Twins and the way you can really rewind your metaverse. I don't know how to say it differently. I like it.
It's been a pleasure. Thanks for having us on. We're excited to share.
We put together a blog post where people can learn more, get some resources. We'll bring up a link down here, which is aka.ms/IoT show/Azure Digital Twins data history. Such a long one, but it should be easy to remember. Taylor, thanks again. You're welcome on the IoT show for more on Digital Twins whenever you want. I'm here. Everyone will be here as well.
Hey, it's been a pleasure. Thanks for having me, Olivier.
See you soon. Everyone, thanks for tuning in. Bye.
Bye-bye.